Good morning, everybody.
Morning, sir.
Okay, so am I audible?
Yes, sir.
Okay, so we will wait for 2 minutes and then we will start the classes because some students are till now joining. So we will wait for 2 minutes and then we will start our class. Okay, so let us start the class. I don't think more students will join today. I don't know why the attendance of this class is gradually changing, doing by delay. I have to talk with your department HOD and we will have serious measures on this. So let us see what happens to this and we will talk about this thing with your HOD and I think he will take serious measures on this. Because if this attendance is followed, then it will be impossible to take classes. 5 students are present in the class. Actually, your strength is 40, I think. So out of 40, 5 students are getting into the class. So this is not fair. And what is the important thing is that your CR is not present in this class. Okay, so last day what we taught, well, we have discussed about some serious things, that is to represent a discrete time signal using some shifted unit impulse as a summation of some shifted unit impulse. And we have also discussed about that convolution theorem proof. We have proved the convolution theorem. So we have done these two things in the last class, and we have told that we will do some realization of discrete time systems or discrete time signals and LTI signals. And For that reason, the interconnection of discrete time system must be discussed. So we will discuss about the interconnection of discrete time system today, because I think that is very important for you. So anybody, any problem with the last day's theory or any other thing? Any problem, any questions that you want to ask? Hmm? No question.
No, sir.
Okay.
No.
So let us start today's. Okay. Just a minute. Just give me a second. Okay, so let's start our class. Last day we told about the interconnections. So today we will discuss about the interconnection subsystems. Today is our 18/1/2022. So today we will discuss about the interconnections of discrete time system. Now, what is discrete time system? You know that. And what are the interconnection of discrete time system? We have to know it. So due to our categories or due to our what calculation efficiency, we connect the discrete time systems, smaller discrete time systems, actually not bigger discrete time system, smaller discrete time system to form a larger system. That's why when we do it a larger one, we do the calculation at a time. Because if a small discrete time system is there, then we have to calculate multiple of times. So if I form it a larger discrete time system, then it will be by the use of methods like we have told, there is the arrangement or interconnection style of discrete time system. So we will easily get the calculations must very precisely or very quickly than solving each and every smaller discrete time system. So that's why we take that smaller discrete time system may be interconnected to form larger system. Now, to form the larger system, two possible ways of interconnection are made. One is called the cascade connection. The interconnection two are there. One is called cascade. And another is called parallel. The cascade and parallel connection of two discrete time system with impulse response, how we can connect it? Like if this is our first impulse response H1n, let us suppose this is our first impulse response H1n. So Xn is passed through the system. Xn is our input signal. And then the output is generated. This is the first signal. Xn, then we passed it to impulse response, and then we get the system Y1n. That is the output of the system. This is the first system. Next, again, I send it to another system. This is the interconnection. Okay. H to N. And then we get our desired final output, that is Y of N. So this is a cascade system or cascade connection. There is another connection, that is parallel connection. So this connection will be given in parallel. How? This will be the H1n. And this will be H2n. So now it is connected. There is a multiplier. Sorry, here is the adder, not multiplier. So this system is connecting here. This system is coming here. This is adder, signal adder. And we get the output from it, that is Y of N. And this is our X of N. This is H1n and this is H2n. So this is parallel connection. So these are the two types of interconnection of discrete time system. Now, how to solve these connections, or how to solve this type of interconnections? So first, let us start with the cascade. Cascade connected DT system. So two cascade connected discrete time system with impulse response H1n and H2n can be replaced by a single equivalent discrete time system whose impulse response is given by the convolution of individual impulse response. So what we can write, this is Xn. We passed it through an first impulse response, that is H1n. And that's, I get the output Y of 1n that is passed through another impulse response H2n, and I get the output Y of n. Now to simplify it, when we will do the simplification, we will use XFN as same. These two will be convoluted to get the resultant value. That means H1n will be convoluted with H2n. And that will give you Y of n. So this is the cascade connected DT system simplification. How can we simplify? Now there is a there is a assignment for you that I will give it today in the Google Classroom. There, your second assignment. It is of 20 numbers. Is to prove that the overall impulse response of two cascade discrete time system is given by the convolution of individual impulse response. So what is the statement? The statement is, I'm going to the next page. DSP. Today is 18/1/2022. Assignment 2. I want to tell you again, those who are giving late assignment, their assignment will not be granted. And you know, in the Google Classroom, it is already shown or already remarked that who has submitted the assignment late. And please don't give any excuse that I was traveling, I was out of station, I was etc. and all that thing. I want to tell you again, prior permission from the HOD or prior permission with the class teacher, you can submit the late assignment. But before you don't take any permission or any individual, if you don't communicate with any individual, after submitting the assignment, if you write that this is the cause of late submission of assignment and etc., that excuse will not be granted. So I am telling everybody, our first assignment in DSP, many of the students have submitted it late. 1 minute late is also a late. So those who students have submitted late, their first assignment was cancelled. So no number for their first assignment. So they get a big 0 in their first assignment. So this is the second assignment. Again, I am giving you time enough time, not time, enough time to do this assignment. And if you not submitted it again within the time, you will be not be counted for the numbers. So it is fixed and it is strict. I am repeating it several times in the class. Those who are attending my class, they knows the rules. Those who are not attending, they does not have to bother any rules because they are not interested in the class. So no problem for that. I will not give this instruction in the group so everybody could see or all other things. So assignment 2 is that to prove there are two assignment will be, means two questions will be to prove that the overall impulse response of two cascade discrete time systems is given by convolution of individual impulse response. This is the first assignment, first question. And second question was to prove that the overall impulse response of two parallel connected discrete time system is given by sum of individual impulse response. So understand, one is the convolution of individual impulse response. This is the convolution for a cascade. And